Pikachu, I choose you.
Penis. Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. No, don't poke my power out, but poke the subscribe button. Actually, yeah, no, never mind. Right, so today we're going to be looking back at this NVA AP50 stereo amplifier rebuild. Basically, it is now more than a repair. Well, it is a repair. One thing I should really do is test whether or not this LED on this front panel, which is just there next to the N, actually works, because I haven't done that yet. So, because I'm going to have to, that is terrible, I'm going to have to re-glue this panel back onto the woodwork here after I've sanded this back. Okay, so I've got my PowerTech power supply running in the background there at 12.8 volts. I've got a 4K7 resistor connected to the binding post, the positive one, to this lead here, which goes to the LED, and this is connected to the negative. I know they're the same colour, but if I turn this over so I can see what I'm doing, we can see that the light does barely light up. That's only because the dropper resistor is so large. Now, the reason I've got a 4K7 is because this power supply is 42 volts plus minus either side, right? This is going to be obviously a 1.84 volt voltage LED, so its maximum current is going to be 20 mA. So you could do the math, and if you were to divide 40 volts, because we'll say we've got 42 minus 1.8 is going to be, we might as well round it off to 40. Then divided by the current that we want, which is 20 mA, that's going to be 2K. So I don't want to run the LED at its maximum current, I actually want to run it at 10 mA. So that is now going to be 40 volts divided by 10 mA, which is 4K7. Well, actually 4K. But I'm going 4K7 because it's a little bit higher, and it's, you know, doesn't matter if it's slightly higher in resistance. Thing is, you don't want this thing just like lighting up like a, you know, bright in a dark room, is what I'm trying to say here. So that'll be the first thing I do, is I will solder the dropper resistor and the leads directly to the LED, gently straighten these without putting too much stress on it, because I do not want the leads to break off, because it'll be a real bastard having to take that LED out. Which, by the way, I don't know if you can see down there, but it's got a lens on the outside, which is what the light comes through, but the LED is actually just glued to one side of a large hole. Because you can see the light directly through the hole. So that LED is not even glued in properly, it's just glued in sideways. I'm not sure what they glued it with either, probably super glue. Right, so first thing I'm going to do though is I'm going to get some sanding block, and I'm going to sand off this surface, because I'm going to use probably what a lot of people are going to disagree with me on: construction adhesive, i.e. liquid nails. Yeah, it was glued there too. I think I've got that piece that went there, that's missing. Anyhow, it's the strongest glue I can think of that will adhere to both wood and plastic. So that's what I'm going with. But first I've got to sand this back so this panel will go back on flat, because otherwise there's going to be a gap here at the bottom, which we don't want. So that all has to be sanded. So that's what I'm going to be getting on with now. And, oh, there it is, it's actually glued to the panel. Because, yeah, that's the orientation. No, that's the top. So we're missing one for the top. I don't suppose it really matters because the metal panel that goes on top will won't bend anyway. But having a look in this box of parts here, I have actually found the bit of plastic, I think this is, that went here. However, or actually here. However, I'm not going to glue it there, I will glue it on the top. So that our top has something to rest against. So, yeah. Alright, so let me get to sanding this back and I'll show you the progress. I broke it. No. I actually took it apart. I actually broke off the back panel. When I say break off, I mean I broke the glue bond between it and the wood. Didn't break the plastic. Plastic's already broken. There's a good look at the piece that's missing. I took this off because A, someone had glued this on wrong. In other words, they glued it up too high. So the top lid, which is also the same material as this, metal, will never lay flat with the sides. It'll always be up at a slight angle, so they glued that on wrong. Plus, I want to address all these fuse holders and the wiring over here. The heat shrinks missed on the neutral connection to the transformer. And yeah, basically they haven't even earthed the chassis, they've just cut the wire off. So the chassis really should be earthed, and that's another thing I'm going to do as a modification, is I'm going to earth the chassis. And address this power cord and put it back in with a new grommet, etc. So I'm not worried about gluing the back panel on right now at this point, because I'll have to go out to JCar and purchase a new fuse holder for here because the center is missing. And in actual fact, I wonder what size fuse we're using. I've lost my screwdriver somewhere too. I had a little flat blade around here earlier. Flat blade, maybe. Alright, give me a second to find what I've done with that. I found it was outside on the ground where it dropped. I had it out there earlier, trying to get some of the glue to come off. Okay. Oh, the fuse is stuck in there. Good luck trying to get that out. I got him out. I can see why it was jammed in there. It's wrapped in tin foil. So, can't tell if that fuse is blown because it's too dark, but they've used a slow blow in there, which is kind of the wrong fuse to use on a speaker output. It should really be a quick blow. But I'm not sure what the foil's purpose was, but yeah, it's gone now. It's a 1.5 amp, which is kind of small, I would think, because I'd have to calculate what the output current at full power is into 8 ohms, so I can work out what size fuse to actually put in there. It never had fuses in the first place, and I think this fuse is actually dead. Yeah, that fuse is open. That's what the tin foil was for. Okay, well, we know that that's dead and needs replacing. I was going to replace it anyway because I don't like the fact it's a slow blow. But that's another thing to add to the list. So as I'm going to be rewiring this anyway, I might actually disconnect. That's even bad there too. I can see the end of the wire. I'm going to basically negate all this crap, cut it off. I'm going to start again. So I'm going to make it so I can get this back panel off, and etc. And I can get the back panel out of my way. Oh, Jesus, that's bad. This whole entire thing is just bad wiring. Look at the exposed copper there. I mean, it's probably not going to be that much of an issue, but yeah, I just don't like it. It doesn't actually scream safety at me. It doesn't scream anything, to be honest. Okay, so this is going to have to go, because I'm going to have to rewire that and I might as well rewire the fuse socket as well. Well, I have to because I've got to lengthen the wires to use the ground. But I will unsolder this one so I don't have to like cut it. They haven't wrapped it, which is good, I suppose. Alright, so that means that that should now be separated from the unit, which it is. That's now going to make things a lot easier to do. And you're probably wondering, why am I doing all this work now without replacing the output stage transistor over here? Well, I haven't ordered the transistor yet. It will be ordered before the end of this video and put in. But what I want to do is, that's not going to be happening for at least 2 weeks yet. So in the meantime, I'm going to work on other things on it. I do have another amplifier to look at, which I will look at probably tomorrow and make a video on it. Today I want to spend most of it just pissing about with this. So now I can put these panels, these bits of wood, back onto the chassis, screw them down with these exceptionally long black painted screws, and they'll allow me also to stand the unit up on its back, because there's no back panel in the way with things sticking out now, which will make it easier to glue the front panel back on. But before I glue the front panel on, I'm going to have to wire in the LED and drop-in resistor wires. So let me get this all assembled back together. Should really invest in an electric screwdriver. I am getting older and I'm not as dexterous as I used to be. Right, just move this wire out of the way. There we have the sides back on now, and I did mark their orientation with a bit of tape on the inside so I could see which one was the left and which one was the right and which way is up. Now, as for the front panel, that will sit on there like that, and when I go to glue it, I will be able to eyeball, you know, the joints, to make sure you know that they're butting up against everything and it's straight. I don't have any clamps big enough to clamp this, so I'd have to hold it for a few minutes so it can adhere. Now that should be fine. I should probably double check with the top panel that the thickness, which it should, I don't see any reason why not, that this gap will be, you know, clear, I mean flush. So wiring out of the way. Just going to prop. Right, so that's the panel on. Oh yeah, that'll be perfectly fine. Yeah, there'll be no gaps there at all, no lips either, so they can just go flush up with the bottom panel, and we'll be good. Well, I'll be good. Oh yeah, joining me as well, I suppose. That gap that used to be here has now almost vanished, so that's good. It's nice and flat now. On to addressing the LED wiring. Hopefully I don't break it, because I'm going to have to break it out of there and put a new one in. I do have to go out to JCar later when they open, so I can get a new fuse socket, a couple of fuses. Sesame Street. I am not going to do what somebody did originally and wire it off of the power amp's power rail, because that looks nasty as heck. I'm actually going to do the right thing, and I'm going to wire it back to the actual filter capacitors, which would be a much better idea. So what I need to do is I need to get about a good length of wire here. That should be long enough, because I'll have to trim him down anyway. And I'll get another bit of different coloured wire, blue for the cathode. Cut him the same length, or thereabouts, because they've got to go to, one has to go to ground and the other has to go to the filter capacitor on the left hand side. to the positive. I'm not going to wire it to the negative. It doesn't really matter which way you wire it, but it is probably makes more sense and more conventional to go from the positive rail to the anode through to the cathode down to ground. So yeah, there is that. I'm going to have to buy some more hookup wire, running out of white. So I've got my resistor, I've got my wires. I need a pair of wire strippers and some heat shrink. Heat shrink, check. Wire strippers, check. Okay, move that resistor before I lose him. So I'm just going to strip off the end of the wire here. I'm not going to worry about the other end just yet because, well, I have to wait for the glue to go off on the front panel when I glue it in a few minutes before I can even attempt to wire it in. Carefully bend these leads back up with them out breaking off. Without them breaking off, let's try English. Okay, the heat shrink I'll worry about in just a moment. That's still at an angle because the LED's at an angle, but what can you do? So this is the cathode and that's the anode because it's the longest one. So I'm going to cut the cathode down smaller so I can then solder this wire onto said lead. And this will be much neater than it was in the first place. So I'll just tin this up and tin this as well. Got the shakes this morning. It's old age catching up with me. Okay, that's that one done. So now what I do is choose a couple of appropriate bits of heat shrink to do this with. I don't know if that's, might be. Just wondering if that's going to go over the body of the resistor. That's the wrong lead. Actually, I'll just cut a little bit off with scissors. I'm going to need him about that long. So that goes on this weight wire. Well, it fits over the wire, so that's good. Will it fit over my solder joint and the resistor? No, not easily. Okay, so I need the next size up, which is this one. If I can get it out, this stuff. So this shrinks down to half its size anyway. That long, and I will cut another length for the other wire, the same size, and there's my bits of heat shrink. And yeah, I hope I'm not boring anyone at the moment. When I come to edit this, I'll try and make it a little more concise so it's not too long and boring, because honestly, who wants to see me rewiring a LED? Anyway, so let's get the flamethrower out, aka my cigarette lighter, and try and get this in the shot. Tripod's kind of in the way at the moment. Oh, I actually burnt the wire. Damn, lucky it's on the bottom. I was a bit too close to the work, but I've only just marred the outside insulation, that's fine. Okay, that's the LED wired in for the most part. So now we can return our attention to attaching the front panel back to the side or sides. I've got a brand new tube of liquid nails, so I'm going to apply a liberal amount. I don't want it squirting out the edge of the sides here, so I'll make sure it goes onto the inside edge more than it does the outside. God, I've got the shakes, man. Don't know why. Okay, that should be enough. I do have to find a screw to shove in that. Grab my panel. Turn it the right way up. And place it on the work. Push it down, squeeze out some stuff. And it did sort of come out the edge anyway. That's fine, I guess. It's not too bad. Okay, so I will need to place a weight on top of this to like help till the glue goes off, because I don't have any clamps. No. Let's try something a little bit heavier. There we go. Always a good use for a speaker that doesn't get used for anything else. As stupid as that looks, it's a weight. I'm using the other one as well on the other corner or other side. So gap's not too bad in there. Quite pleased with that. I'm not going to get it perfect, obviously, but I've got to leave that sit for about 15-20 minutes for the glue to go off before I can turn it over. I mean, I could have actually glued it the other way by turning the unit upside down and actually putting the face on the desk and then using the weight of the unit to actually push it down, but yeah. But before this hardens, now is the perfect opportunity to make sure everything is flush and square, because once it's glued, well, there ain't no way going back, is what I'm trying to say. So righto, I'll leave that sit for a bit and we'll come back when it's handleable. I've done quite a bit of work off camera. I've soldered the LED in, so one side goes to the ground, the blue wire, and the anode's going over here to a positive, which is nice. When I took the back panel off, there was a wire strap that went to the input connection grounds, and it ripped it off and bent it. So I've cut that off, and now I've got two green wires here. So one will go to the back, and this other long one goes towards the front to ground the pot. And really the pot should be grounded at the input side close to the power amps, but yeah, it's not. I glued that bit of plastic that was just lying around in here so the top's got something to sit against, so I didn't see the point of gluing it in the bottom where it was, so that's fine. I've lengthened the power cord and put a new grommet in. In other words, I've lengthened the wires that come out the power cord. Filed the hole out a little bit bigger so I could get the grommet in there. A couple of cable ties either side as strain relief, which is not really going to be that helpful. What I might do is I might run a bead of hot glue around the inside edge of the grommet here so it makes a more permanent, well, permanent joint, I guess would be the good word for it. So now what I'll do is compile a list of things I need, which is one fuse holder, a couple of 3 amp fuses I've chosen. I think 3 amps should be more than enough. And then I can then unsolder all this crap and rewire all this shit, and so it's better wired. Rewire the power cord back on, and then I can glue the back panel back on. I've got it sitting on its face on the desk because it wasn't quite set enough, and I leant on it and it slid downwards. So I'm using basically the weight of the transformer to glue the front panel to the woodwork and let it set that way with weight on it. And I'll do the same thing for the back panel. I'll turn it up on its back end and find 2 bits of wood that are the same height so I can prop the edges away from the desk so I can clear all the shit that comes out the back here, including that switch. and then use the weight of the transformer again to set it up, and then I can move on to the electronics. But I might get to the electronics first before gluing the back panel on, so I can just test this module out. Right now I'm going to compile a list of components I need, as I just said, 2 fuses, a fuse holder, and I'm going to get some resistors and do away with this mess that's in here. But I'll replace the burnt resistors first and then get everything wired in correctly and etc. ready to test. I won't connect the power supply rails directly to here yet. I'll just use some jumper leads for that stuff, just to start testing it first. If there's no unusual current draw and we have the same voltages at both bases between the 2 modules, excellent, we can move on. Alright, and I've been to JCar and I'm back now, and I've got the parts that I need. I've got some new 0.47 ohm resistors there, 4 of them, 3.15 amp fuses because I didn't have 3 amps, it's neither here nor there, and a couple of packets of 10 ohm resistors, 1 watt devices, and I'll get to those as to what they're for later. But right now I'm going to install the new fuse holder and start getting everything on the back panel reconnected to make it power on, so we can then test the other module. Alrighty then, everything's now done. I've rewired it on the main side as best as it's ever going to get. Put the new fuse holder in, wider wires to it. Now I've got this transistor soldered back in, the 2 resistors are replaced that were burnt. This one was challenging because when I took it out it actually lifted the pad on the other side, so on this side here, so I just routed the lead of the resistor around to this transistor where it goes, just to strengthen the track. So now I've got this turned on the on position, dim bulb off. This is not connected, I'm just going to make sure the thing still powers up, which apparently it does. And then I'll chuck some jumper wires in there. So I'm just going to measure between ground and our output connection. Yeah, it's 137 odd millivolt there. It's pretty high. I don't know why it's that high. It shouldn't be. Got something in my eye now. Prick. Alright, so the LED, by the way, is actually glowing, I think. Yeah, it's awfully dim though. It is glowing, but it is kind of dim. That was kind of unexpected. But it is glowing. I mean, it's not very bright, but whatever. Right, so I'll hook up some test leads to this stuff here, and we'll just now do another double check. Alright, the test leads are in. I think it's connected right. Got positive connected there, negative there. Transistor is removed. I've got solder splash on the capacitors. Alright, here we go. No issue. Alright, there's no smoke either, that's great. Let's just have a look at what our output voltage is doing, which it shouldn't be that big of a deal. We're at about minus 700 odd millivolt there. Okay. At the base of this transistor, we've got 45 volts. Nothing there. And if I can get on there, we seem to have the supply rails there for some reason. There may be still a fault with this particular amplifier module. It's hard to tell. So yeah, so for the moment I'm pretty much going to leave it until I've got the transistor, but it's the voltages that are concerning, so I'm going to have to go through this particular PCB and go through the next one to it and measure voltages all around the circuitry, just to determine like what voltages should be where. Like for instance, if I connect to there, now I've got my multimeter free. At the base of that, there's like supply voltage, and the base of this one doesn't have the supply voltage. So yeah, there's something issue-wise with this particular module that's causing it to have quite a high voltage at the base, which is not right. So yeah, all the other components check out, like transistors and semiconductors. I haven't tested like resistors yet, so I'd have to go through all of it and just to determine what's going on here. Nothing's getting hot though, so that's alright. So yeah, that'll be a test I'll do off camera, and then when I eventually find the problem, I'll let everyone know. I'm still not exactly 100% happy with that LED because it's not very bright. It is there though, so alright. So now I can turn my attention to gluing the back panel back on, and then moving on with this project. Alright, it's a couple of days later now. I've actually been through all the passive components apart from the capacitors on this board, and I did find that the 0.68 ohm resistor here in the emitter generation was open, so that gave me the opportunity to clean this mess up. So I put two new 0.47s in it. It doesn't make that much difference as long as there's some degeneration there. Just helps control thermal runaway. Now, as soon as I put this new resistor in and had the transistor connected without the PNP in, well, this resistor, this new 47 ohm resistor that I put in, started smoking again, and the dim bulb was glowing quite bright actually, so it was driving this transistor hard on. So I've looked at the schematic, but down here there's a Zener diode. It's a 3.9 volt according to the schematic anyway, and that goes across each base of these two driver transistors. Well, these are actually the VAS transistors. The driver transistors are already in the output devices via 247 ohm resistors. So the cathode of this Zener connects via this resistor here to the base of this transistor, and conversely the anode connects to the base of this transistor via this resistor, and this 0.1 microfarad 250 volt capacitor bypasses that Zener, so it's actually going across the Zener. That was a weird noise. What I'm going to do is I'm going to use the good module, and I'm going to measure what the voltage drop across that Zener diode is. It should be 3.9 volts. But first, I'm just going to make doubly sure that the Zener diode is still functional. So we go that direction. And yes, it's conducting. If I go in the reverse direction, nothing happens. Okay, that's fair enough. So we go into voltage mode now, and I turn the thing on. Now I measure across the good circuit, across this diode here, and we have 3.8 roughly volts there, almost 3.9. Measure across the suspect channel, we've got hardly anything there, almost zero. Okay, so if we now measure between ground and the anode, the cathode of the good one, we should have 1.9 volts. And on the anode side, we should have 1.9 volts negative. So that one's positive, and that one's negative. Bad channel. we've got the positive supply rail. The positive supply rail should not be there. And again, almost the positive supply rail. So we're not getting the negative supply rail to this side for whatever reason. I feel like an idiot sometimes. I've lifted the bases off the working channel, and across the diode over here we have nothing. Between ground and the NPN base we have got the full positive side voltage, and on the other base the same. So it looks like the transistors have to be in circuit for that circuit to operate correctly. So I feel a bit dumb. So what I'm seeing over here would be right. However, when I connected this transistor up, it smoked. Okay, so I don't know if anyone's actually wondering, but if anyone is, why is this transistor, this PNP TIP146, shorted between the collector and emitter pins? Well, if we look at the data sheet for both these transistors, the NPN counterpart and the PNP, that's the NPN, right, and here is the PNP. I'll draw it like that. Now, according to the data sheet, across the collector and emitter, there is actually a diode, which is in the reverse direction of the current flow. So normally this would be towards the positive rail of the circuit, and this is towards the negative end, so the diode's in the reverse direction to the current flow. And this is what is basically known as a flyback diode, and on the NPN we have the same diode, also going in the reverse direction. This side would connect to the negative, this side would connect more to the positive. So this diode is also in the reverse direction of the current flow. So these are flyback diodes, and they are supposed to protect the transistor from like transients on the output, like spikes and stuff, just to keep the transistor from shorting. So what I think has happened, and in the circuit we have two resistors here, both 0.68, right, and that goes to our output, to the speakers, and so these are the degeneration resistors. So what I think's happened is at some point this output has been shorted to ground, somehow by just shorting the output leads, or the speaker went short circuit, whatever, and that's caused current to flow through the wrong way through this diode, and just basically it took the diode out. So this diode is now completely short circuit. So that's why we're now seeing a short between the emitter and the collector, is because this diode is now basically a piece of wire. So physically measuring between the junctions tests okay, but between this point and this point it's dead short because of this diode. Now if this diode wasn't here, you wouldn't see the short across the emitter collector. You could still get a short across collector and emitter, but that's the reason why it's shorter between collector and emitter. And this is why it's always a good idea when testing transistors with a multimeter is to check between the collector and emitter for a short, because the transistor may conduct okay between base and emitter and base and collector and do nothing in the reverse directions, but if there's a short here, well, this whole entire transistor is now kaput. You have to replace it. So that's what's most likely happened to this one. So I've tested everything in the circuit, and what happened during that short circuit, it ended up driving so much current through the load and then back through the negative feedback circuitry of the amplifier. It actually also caused this resistor to go open, and there's a couple of resistors in series on the base of the NPN transistors, some 47 ohms. And those started to get hot and smoke. Might be helpful if I put it in the shop. These started to smoke because it was driving this transistor on hard, so there's a lot of current flowing through here. And eventually what saved it was one, I believe it was the PNP transistor. The emitter actually got so hot, it actually desoldered the wire that went to the board and caused it to pop out. So that removed the short from this part of the circuit. And at some point, this resistor just overheated and went open, which then stopped these resistors from smoking because it's no longer having current flowing through the short here. And that's including even if the output was no longer shorted. So that's my take on that. So if I replace that transistor, and I've replaced the two driver transistors that go in it, or the VAS transistors, they're actually TIP41 and 42 Cs now respectively. There's nothing wrong with the old ones, but I had them, so I thought I'd change them. I can't find anything physically else wrong with the module, so I'm pretty confident putting in a new transistor is going to fix that module. And I have replaced these 68 ohm resistors here, both of them, because that was a mess, to 47 ohms. It's 0.47 ohms. There's not much really in it between the 68 and the 47. They're only there to just limit the current in the emitter of the output stage. As long as there's some resistance there, half an ohm should be fine. So I'm going with that. The other module, I'll change those 68 ohm resistors, those large 3 watt devices, into 5 watt ones, 47s as well. But what I might try before ordering the transistor is, I know that the PNP on the working module side is fine. I can just unsolder that transistor and just put it in the non-working module and see if the module fires up. Thing is, you cannot have this transistor's base connected to the circuit here, because without this transistor in circuit, this one starts dumping current into the feedback path, which causes these resistors to start smoking. I found that out the hard way too. So both these transistors on the working module have to be unsoldered, so they're out of circuit, and then we can go ahead and test with the new transistor, well, the working transistor, and see if that module works. I'm also going to replace these 47 ohm 470 picofarad, I think these are polyester capacitors, with some 50 volt disc ceramic, because some of them were next to those resistors that started smoking and they've gotten hot and started melting. So, but they look and they test perfectly fine as far as I can tell. So I'm going to replace all 4 of these on the board with some new ceramics before putting the transistors in, because they add a little bit of extra stability to the output stage, so I'm not going to operate them without them in circuit. Put it on the dim bulb, see if the power amplifier comes to life and no magic smoke starts getting released. And then I'll order the new TIP146 transistor from somewhere online, and then put it in the currently working module and get that all back together, and then we should have a working stereo amplifier. Wish me luck. Well, the new TIP146C, it should be a C anyway, TO247 transistor has arrived for the NVA unit. In fact, I've actually had this sitting around for a month because I know what's coming next, and I'll explain that after I put the transistor in. And this came from Wagner with a flat delivery fee of $9. So let me get the transistor in, and we'll get it all set back up by connecting the supply jumper leads back to the power amp module, dim bulb, etc. And then I'll explain what's going on. Okay, the transistor is in, and I've verified with the other side it is supposed to be TIP146, not a 146C, so that's fine. They're both the same type of transistor. So there shouldn't be any issue there. So I've got the unit turned on at the back here, but the supply, well, the dim bulb turned off. Solar splash on that capacitor. Whatever. Alright, turn the dim bulb on. And that's what it's doing, glowing brightly. That's why I've had no motivation to do this. Although I can't see any smoke. And nothing appears to be getting hot. So what's the supply rails doing is the first thing we should find out. I'll just leave that there, hopefully you can see it. So between ground and the positive rail, there's 11 volt DC, and between that and negative, 11 volt DC. So the supply rails are even. They're not like wildly different, which is an indication that, well, it's trying to work. However, these output transistors, both of them, are getting slightly warm. Now, if there was a dead short, that would not happen. So the output is about 6 volt DC. So I'll turn that off. I'm just wondering if it's something that I've done to this, because I have put 470 picofarad capacitors, ceramic capacitors in there. The originals were actually polystyrene or polyester, and obviously I cannot get those style of capacitors. Not in polyester anyway. I can't get 470 polyester, put that there. Yeah, so the only way to verify that is I'm going to, it's only 6 volt DC, which is not going to kill anything. I'm going to measure with an oscilloscope at the output to see if we actually are oscillating. Because I do know that there are no blown components. I'll leave that in times 10 just in case. So yeah, all the transistors do check out. The only things I've done differently, apart from those, 470 picofarad capacitors, is I changed these drivers to TRP41 and 42C respectively. That shouldn't be an issue because they're electrically the same as the TRP31 and 32C respectively. The only other change is the generation resistors were put down to 0.47 ohms instead of 0.68. Again, that shouldn't cause an issue. That would just mean that now that there's less degeneration on the output, therefore the output stage can heat up more, and we'll have a slightly higher quiescent current. So what I'm going to do now is I'm going to turn your attention to the scope, and I'm going to turn it back on and see if we can get something on the output which is not correct. Alright, you can look at the scope screen. I'm going to turn the load back on, well, the dim bulb on. Well, it didn't seem to show anything there at the moment, so I might make sure. Well, I can't see anything, so I'll change it back to times 1. I can find the switch. There's nothing there. Just a bunch of random noise. Oh wait, no, I'm wrong. Yep, we're oscillating, look at that. It's oscillating at 100 Hertz. Nasty. Okay, I'm going to turn that off. So, yeah, that's the reason why it's drawing current and the dim bulb is dimming it down, is because the amplifier is oscillating. So I think it may be these ceramic capacitors is doing that. So the only way I'm going to verify that is to pull the board back out, remove these capacitors, put the originals ones back in after I've verified that they're still functioning. They should be, even though that one of them's melted because it was right near this resistor that was getting hot. But from what I saw, both output devices are now contributing to the signal, except it's just oscillating. So as these two 470s are right between the base and collector, I believe, of these two output transistors, that may be having some effect. There's one down here which may also be contributing. So I'll just check all three of the old capacitors first, and then I'll just put them back in. But it looks like the drivers might be functioning fine. I don't know, but we'll find out. That's my next step, is to pull the board back out, change those capacitors back over, and try again. Right, all three of those capacitors are changed back. However, same problem. It's still oscillating at 100 Hertz, and I do not know why. So that's a shame, because I was hoping that would just, work flawlessly without, too much pissing around. But yeah, now I'm absolutely gobsmacked and confused as to why it is oscillating. There's no reason for it to oscillate. I would have thought, yeah, okay, I use different types of capacitors in there, ceramic versus polyester, but that didn't seem to be the issue. But it does look like this amplifier is inherently easy to get into oscillation, which is kind of annoying. So I don't know what I'm going to do here, because I can't think of what else could be causing the issue. As I say, the transistors all check out, and we're getting a signal through the amplifier. It's just an oscillation. So if anything, that'd be coming from the input stage, I would have thought. I don't know, maybe. But yeah, I'm confused. So I would have loved to have got this working in this video, but this video is going on pretty long, so I need to, finish the editing on that. Unfortunately, I can't get this to go any better than it's going now, which is annoying, but it shouldn't be the degeneration value resistors here. I wouldn't have thought that would have caused a problem, although it may. So I might want to put like 0.18 ohm in series with each of them just to test. Yeah, I wouldn't have thought these two transistor drivers being changed would have affected it. So I'm going to leave this video here, and if anyone's got any thoughts as to why this could be oscillating like it is, because I'm out of ideas, let me know down below in the comments. But for now, most of the reconstruction has been done. I've replaced the LED with a clear white, well, not a clear white, it's a diffused white, 1000 micro candela or something. One, because there's already a red bezel cap thing in the hole, and the old one was just drawing way too much current, and the limiting resistor was getting way too hot. So I changed the LED. So that's done. So yeah, now all I've got to figure out is why it's oscillating. So if you enjoyed this video, even though I didn't really fix it yet, please let me know by going down below, like, commenting, and subscribing if you haven't done so already. Anyway, this is Yasho30 saying, see you later. I'll see you in the next video, and this will be revisited eventually, but currently I've lost all motivation.